All right, hey, good morning. This is the lesson for Tuesday. I am recording this video from my house, actually my sister's house. So I know the setup is a little different, but we'll be able to get through everything just the same. We're on page 427 of lesson 89. So make sure your math books are open. Make sure you're following along as I go through the lesson. So page 427, lesson 89, we're talking about faces, edges, and vertices. The illustration here points out the face, a face, an edge, and the vertex of a cube. And here we see this part as labeled the face, and then our edges where the faces meet, and then the vertex where the point where the edges meet, okay? So we're gonna count how many faces, how many edges, and how many vertices there are in this particular cube, okay, or in a cube. So letter A cube has how many faces? So we would count it, I've got a little object that could help us here. So if you ever played a game like, I think Monopoly or any other game that uses a die, you're familiar with the cube, okay? And so if we count the faces, you probably can't see it, but I put little numbers on them. You've got 1, 2, 3, and 4, and then you've got 5 and 6. So 6 faces on the cube, and so the answer to letter A would be 6 faces. Then letter B, a cube has how many edges? Again, you could use your, you could use a cube or a die that you have at home to count those pieces. So first we're gonna go around 1, 2, 3, and 4, and then we're gonna go around the front, 1, 2, 3, and 4, and then we're gonna go over the top, 1, 2, 3, and 4. So we've counted that there are, in fact, 12 edges to our cube. And then finally, a cube has how many vertices? And again, the vertices is where the point or the edges meet, okay? So we'll count our corners, 1, 2, 3, and 4, and 1, 2, 3, and 4. So we see that we have 8 vertices, or corners, 8 corners. And we count those off there. Next, we're looking at a pyramid here. I've got it here on the board, but you also have it there in your books. And here's a pyramid with a square base. We see that at the bottom. One face is a square, so the bottom face is a square, and the rest are triangles. So how many faces are there? So we can count. Let's put this down here. We count the bottom face is 1, 2, 3, 4, and 5. We see that this pyramid has 5 faces. Then letter B, how many edges? So we can go ahead and count them. 1, 2, 3, 4. So that's the square base. And then we count 5, 6, 7, 8. We have 8 edges. We go ahead and write that down. And then how many vertices or how many corners? 1, 2, 3, 4, and the last one, 5. Ooh, that was a really ugly 8. Go ahead and write it over here. 8 and 5. Next, on the next page, we have a triangular prism. How many faces does this have? Here we have a rectangular base. So 1, 2, 3, 4, and 5. This triangular prism has 5 faces. How many edges? We can count them here. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 edges in this triangular prism. And then how many vertices? We count the corners. 1, 2, 3, 4, 5, 6. We have 6 vertices, okay? And lesson 89, we're doing all the problems, okay? We're doing problems 1 through 30. Don't worry, Wednesday and Thursday, we'll split lesson 90 in half, and you'll do just 15 problems each day. But today, we're gonna go through all of them, and I'll do the odd numbers with you. So let's jump right in. Problem number 1. What is the average of 4.2, 4.8, and 5.1? And as you know, to find the average, we need to find the sum of all the given parts. So we have 4.2 plus 4.8 plus 5.1. Very important when adding decimals, make sure that your decimals are lined up or else you'll get the wrong answer. So we add up all our numbers to get 14.1. 14.1 then becomes our dividend. We count our parts, 1, 2, 3. So we're gonna divide it by 3. So 14.1 divided by 3, I see how many times 3 goes into 14 evenly. 3 times 4 is 12, I write 12. We're going to subtract 12 from the 14, which gives us 2, bring down the 1. All right? And then I need to see how many times does 3 go into 21 evenly. Well, I know it goes evenly 7 times, because 7 times 3 is 21. I subtract that, and now I have a 0. Now I don't need to continue dividing or adding zeros because I have a remainder of 0. So our final answer is 4.7. The average of 4.2, 4.8, and 5.1 is 4.7. Number 3. We're doing all our odd numbers. This is going off the question. 15 of the 25 students in room 20 are boys. Use this information to answer problems 3 and 4, and we'll answer 3 here. What percent of the students in room 20 are boy? So there are 15 out of 25. So I've set up my fraction, 15 out of 25, and I'm looking for a percentage. So just like we usually find our percentages here, I'm going to see how many times 25 goes into 100. I'm thinking of quarters into a dollar. We see that it's 4. So 25 times 4 equals 100. Whatever I do to the denominator, I have to do to the numerator as well. Okay? So 4 times 15, we see that it is 60. Okay, so I write 60. So remember, a percentage is any number, is a fraction with the denominator of 100. So our final answer would be 60%. Next, number 5. This triangular prism has how many more edges than vertices? So we have to find both the edges and the vertices of this triangular prism. So let's count our edges first. 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 edges, okay? Now I count my vertices. 1, 2, 3, 4, 5, 6. Okay, there's 6 vertices. And we need to see how many more edges there are. We just subtract it. So we know that there are 3 more edges than vertices for number 5. Again, remember, make sure you're showing all your work in or on a separate sheet of paper. All right, number 7. Describe the appearance of a trapezoid. You can go back to lesson number 78 and get all this information, but a trapezoid is a polygon with 4 sides, okay? So it has 4 sides, and then 2 of those sides are parallel, and the other 2 are not parallel. If you look at the shape of a trapezoid, it has lines that are angled like this, and eventually at one point they'll intersect, which means they cannot be parallel lines. Parallel lines run parallel to each other and never intersect. So make sure you write your the definition of a trapezoid there on a separate sheet of paper. All right, number 9. We have 25n equals 70. Okay, so here we're missing a factor in our multiplication problem. 25 times what equals 75? To find it, we need to divide the product by the known factor. Okay, so we divide it. So 25 goes into 25 one time evenly, so that's canceled out. And then I see how many times 25 goes into 3. If you think of quarters, okay, how many quarters are in 75 cents? There are 3. So n equals 3. 25 times 3 would equal 75. So 3 is our missing factor. Next, number 11, we're looking for the perimeter of this triangle. To find the perimeter of a triangle, all we do is add the sides. We take 25 plus 20 plus 15 to give us 45, 50, 60 millimeters, okay? 60 millimeters. Now, remember, when we add these units together, there's no need to square it. That's only when we multiply units of measurement together. Next, number 13. We have write 125% as a decimal number, okay? So, written as a fraction, 125% is could be written as a fraction with the denominator of 100. So, all I'm doing here is taking 125 and dividing it by 100. Remember, when we divide by a number, by 100, our decimal is going to move however many places to the left. When we multiply, it moves to the right. When we divide, it moves to the left. In this case, it's going to move 2 places to the left. 1, 2, to give us the final answer of 1.25. 125% written as a decimal would be 1.25. And I know it's a little smaller than usual, but if you're listening, if you're paying attention, you'll be able to get it. All right, next, number 15. We've got n over 0.3, or n divided by 0.3, equals 0.2, okay? Here, in order to find the missing number, we need to multiply both sides by 0.4, okay? So remember, when you have a missing number in a division problem, you need to multiply. When you have a missing number in a multiplication problem, you need to divide. You use the inverse operation. So here we're using the inverse operation to find the missing number. We're multiplying 0.4 by n over 0.4 and the answer as well. So 0.1 cancels out, and now I simply multiply 0.2 times 0.4, which gives me the answer 0.8, okay? So if I substituted the n for the 0.8, it would be 0.8 divided by 0.4 equals 0.2. All right, on to the next one, number 17. 25 divided by 0.8, so I've got 25 as my numerator, 0.8 as my denominator. My denominator then becomes my divisor, and 25 my dividend. But because my divisor has a decimal, I need to change it, okay? In order to change my decimal into a whole number, I need to multiply it by 10, okay? In order to move the decimal point to the right. Multiplying 0.8 times 10 will move my decimal point one place over to the right, making 0.8 an 8, which is a whole number, which is what we need to get. But whatever I do to the divisor, I have to also do to the dividend. So I multiply 25 times 10 to give me 250. And then I go ahead and divide. 8 goes into 25 3 times. 3 times 8 is 24. 25 minus 24 is 1. I bring down the 0. Then I see how many times 8 goes into 10. 1 time. 1 times 8 is 8. I subtract 10 minus 8 equals 2. And then I add a 0, okay? I've placed my decimal. You have to add in this decimal, and remember, you have to keep your decimals lined up in the dividend and the quotient. So I've added a 0 and I've brought it down. 8 goes into 20, 2 times evenly. 2 times 8 is 16. And then 20 minus 16 is 4. Add another 0, bring it down. Now 8 goes into 40 5 times evenly. 5 times 8 is 40. Oh, I didn't subtract. All right, 40 minus 40 is 0 to give us the final answer of 31.25. And then on to the next one. We have number 19. We have a 5 1/8 minus 1 7/8. Very important, when subtracting fractions, you gotta make sure that the denominators are the same. Thankfully, the denominators in this problem are already set up correctly for us. But we need to borrow from the 5 because we can't take 7 away from 1. And remember, when adding or subtracting fractions, we're only focusing on the numerators. After the denominator has been changed to be the same, we're only gonna add or subtract the numerator, okay? But we can't take 7 from 1, so we're gonna borrow from the 5, which makes that a 4. And then we're gonna borrow a whole from the 5. This whole is going to be represented in a fraction as 8 over 8. And I'm going to add that to my 1/8. So again, same rule. When adding fractions that have like denominators, we only add the numerators. So this gives us 9 over 8 minus 7, which gives us 2 over 8. 4 minus 1 is 3. Okay, now I've got 3 and 2/8. This can be divided evenly. Okay, both the numerator and denominator can be divided evenly by 2. So my whole remains the same, 3. 2 goes into 2 one time evenly, and 2 goes into 8 4 times evenly to give us the final answer of 3 1/4. Next, number 21. 1/3 of the 24 knights were on horseback. How many knights were not on horseback? So let's find the first part of the problem. I've got 1/3 times 24. My whole number 24 is represented as 24 over 1. Now, I could multiply 1 times 24 and 3 times 1, but what I'm going to do here is I'm going to cross multiply, okay? And I see how many times 3 goes into 24. It goes into it 8 times. So now I do 1 times 8 is 8. 1 times 1 is 1. So I see that my final answer is 8. 8 of the men were on horseback. There were 24 men total. Okay, so I take 24 minus 8. Okay, borrow that. Gives us 6. All right, so 16 men were not on horseback. The next one, number 23, you see that you have a cube that is made up of smaller cubes, okay? What I did is I counted one side 3 down, okay? So it's 3 down, 3 across. So I got the number of cubes, smaller cubes that were in that group. So there are 9 in that group, and there are 3 of those groups. So 9 in each group, and there are 3 groups. So simply take the 9 times the 3 to give you 27 to figure out how many cubes there are in the entire thing. So there are 27 smaller cubes inside the larger cube. All right, number 25 is based off of our lesson 88. Remember, we're looking for the square root, okay? Root goes down, so we're looking for a smaller number. We're not squaring it, we're looking for the square root. So what two numbers times, okay, what two numbers that are the same multiplied together equals this number, okay? So this one's a pretty easy one. 5 times 5 equals 25. Now, with a number like 16, I know a number like 8 times 2 would equal 16, but remember, they need to be the same numbers. In this case, we've got the number 4. 4 times 4 equals 16. So the square root of 25 is 5, because 5 times 5 equals 25. And the square root of 16 is 4, because 4 times 4 equals 16. Then, the original question was the square root of 25 minus the square root of 16 equals what? We see that 5 minus 4 equals 1. Then we're almost done. Problem number 27. Important that we do our order of operations correctly. So we've got 10 plus 10 times 10 minus 10 divided by 10. The first thing we need to do is multiply and divide from left to right. So we do those operations first. So we've got 100, okay? So 10 plus 100 minus 10 divided by 10, which equals 1, okay? These are the first operations that you perform. I wouldn't do 10 plus 10 and times 10 because following the standard order of operations, I have to do multiplication and division first. So I've done that. And now I can add and subtract from left to right. So 10 plus 100 is 110, minus 1 is 109. And this is the correct answer based on the standard of operation, the correct standard of operation. Again, if I would have simply gone from left to right, it would give me a totally different answer. So 109 is our final answer. And then number 29, last but not least, we have 10 centimeters plus 100 millimeters, but our answer needs to be in millimeters. So we need to convert our 10 centimeters to millimeters. So we know that 1 centimeter equals 10 millimeters. So 10 centimeters would equal 10 times 10, 100 millimeters, okay? So my 10 centimeters are converted to 100 millimeters. Cross this out, and now I could add 100 millimeters plus 100 millimeters would equal 200 millimeters, all right? And then lastly, we have 300 books divided by 30 students. And very important here, they're different units, okay? So we've got books and students. These don't go into each other like millimeters and centimeters. So we'll talk about it here in a minute. So I've got 300 over 30. I can simplify this question by crossing out my zeros, seeing how many times 3 goes into 30. It goes into it 10 times. Now remember, when you have different units of measurements, okay, so in this case books and students, the units of measurement need to remain in division form. So I could either write books over students, or I could simply say books per student. For this one, I'm going to write books, it's kind of sloppy, sorry, over students. Okay? Make sure you show all your work in on your paper, and make sure you're ready to turn that in whenever your work is collected. All right, thank you.